I'm going to introduce our next keynote speakers. Darren Thomas, who is Vice President and General Manager of Micron's storage business. He oversees their solid-state storage business, ranging from client hard disk drives to enterprise class storage solutions. He was previously VP and General Manager of storage at Dell. And also he's worked is involved in their acquisitions of EqualLogic and Compellent. He was also VP and General Manager at Compact Computer, where he built their storage business to include server-based storage, mid-range and enterprise storage units. So he's had 30 years of technical experience working in the industry. He also was instrumental in founding the Storage Networking Industry Association. So Micron is going to talk about turning big data into critical business advantage with flash memory. We're expecting an entertaining presentation here, and I see people are getting their glasses on. So I hope that you can see 3D flash. Thank you.
Thanks, Tom.
Take care, Greg.
Okay. All right, well, you don't need those 3D glasses just yet because I am already in 3D. So what I want to do is, first of all, I intend to release a good bit of information, a good bit of opinion on what's happening in the market. And because of that, my lawyers got on me. And so I have to put the safe harbor that basically says your mileage may vary. So, but this is going to be an interesting discussion because I was here last year, and things are going to be a little bit different this time. Last year, if you remember, we had a flash mob. That was pretty cool. We're not going to do that today. So don't worry about losing your seat. And don't leave. We might still do something crazy, but no flash mob. And I want to thank BJ because I couldn't ask for somebody to come up here and introduce a flash company better than Facebook, who is not only one of those visionaries in the industry, but also a company that carries that vision and actually interfaces and changes the way many other IT departments look. They're actually a visionary to other IT departments. So it's great to see their focus on flash, and I got his request. I got the ask. So if you watch, we're going to have the answer for his ask in here. So if you remember last year, I came up here and we were at 5%. I think it surprised everybody with 10 years of work. Everybody comes here, we're all jacked up. This is a great place to come, and we changed the whole 5% of the market. And I hope I didn't offend anybody, but I said that's pretty dang insignificant, and we got to do better. And so let's see how we did. First of all, 2015 was 5% as we predicted. 2016 is going to be 10%. So it took us 10 years to get to 5%, and it's only taken us 1 year to double that number again. Well, why? Well, what's happened in the last 1 year that has given us this kind of prediction that 2016 is going to close with doubling the total bits sold in the last 10 years in 1 year? Well, first thing is I've got this slide from Gartner. And I love this slide, but I'm not going to suggest that I believe it or I want you to believe it. What it shows is these are ASPs of mission-critical drives. So these are 10K, 15K RPM drives, and it shows that by sometime in 2018, you're going to see that a classic enterprise SSD could cost less than a classic 15K or 10K RPM drive in the mission-critical space. Why? Well, because those are the drives that were inching out. And in the Gartner study, it basically said if you still want to buy a hard drive, they're a premium commodity. And you notice that they actually have the price going up. I'm not going to suggest I want to believe this, but I think what it does tell you is the tipping point is close. I don't know if it's 2018. I don't want to use up all my safe harbor on that one prediction. But what I would like to suggest to you is it's not far away. And the other point from my presentation last year was we need to be thinking of beyond just speeds and feeds. If you remember, if you were here last year, I said speeds and feeds are fine, but it's not the only answer we need. So another Gartner study done with IT users, and what they came back with was these kind of savings when they went to flash versus hard drives. Now, pretty stunning numbers, but I'm going to explain them to you. because I had to have them explain to me a bit. Look at the floor space one, the 88% floor space. That's the key to this whole thing. What you can do with flash is for a lot less equipment, you can get that same performance that you had with the hard drive system. And because capacities are growing so fast, you can get a capacity per spindle, per drive, significantly outweighing what you did in the past. So you don't need a rack full of equipment. You can deal with a much smaller, 88% less. And when you do that, your cooling bill goes down and your power consumption bill goes down because you're just using less equipment. So one of the benefits of flash, not necessarily just speed, but related to it, is your end user customer can get a lot more functionality out of a lot less equipment. Why is that valuable? Because they pay for those electric bills, and there's many, many countries around the world where you've hit a limit. You're at the power limit, and being able to save 88% is pretty significant, or 77%. The last one I want to point out is maintenance. I think it goes kind of unheralded that SSDs have failure rates that are closer aligned to a piece of silicon, because that's what it is, as opposed to, spinning, moving parts. And so you're going to see maintenance costs be significantly lower. Now, it's not always the case. I think we as the investment community that builds into flash, we're going to have to start coming out with new architectures that take advantage of this lower performance. Why have 24 hot plug drive bays in a system where the drive failure rate is 1/75th of what it used to be? Why would you do that? Why would you put them on a hot plug drive tray that costs money to have an empty tray sitting there? It's got connectors, it's got power going to it. Why would you do that if your failure rate doesn't warrant doing it? So there's significant savings in maintenance that I don't think we fully accomplished. But this is what customers are seeing today. And what I want to remind you is this is significantly based on 3D TLC, and 3D QLC. So Micron, as an example, by the end of this year, we're going to be approaching 60% of all of our production is 3D TLC. And by the first half of next year, we're going to be introducing 64-layer 3D and 3D TLC. And it won't be long after that, we'll be introducing QLC. So I hope BJ's still back there. You can tell him we got those products coming. All right, so you might have seen this logo, this accelerated logo with Micron. It's something we did. We're tying the acceleration that you just saw. We're tying that acceleration to 3D because I think Gartner's doing it. I think everybody's seeing that 3D makes this kind of a significant change in the market. So what I'd like to propose to you is there's three major markets that we sell into with Flash. The first one is mobile. You saw our mobile team this morning, the Micron mobile team, announced their very first 3D device in a UFS 2.1 interface. So we have our first 3D NAND. Now what does that do? Well, 3D NAND can be much bigger and a much smaller form factor, a larger capacity, smaller form factor, and a very good price point. Well, what that does for a handset is everybody's got flash in their handset, but you have a very small amount of flash. And so as a result, when you get an app, you're getting, what is it called? An applet, right? You're getting a baby app. Well, with this technology, there's no reason to do that anymore. You can now have the size NAND and DRAM that's available in a tablet today. You can run full-blown apps on your cell phone with the amount of capacity that 3D NAND brings with technologies like UFS to the handset. And so accelerating the mobile solution set. Let's take client for a second. If you look at the client market, what's happening here? Well, we announced two of our new products, the 1100 and the 2100, which is our client SAS drive and our client SATA drive and our client PCIe drive. And those two drives, both 3D, they're brand new 3D technology. And what we're able to do is start to approach capacities that you haven't been able to see before in that small form factor. Matter of fact, we're talking about terabytes now in a third the size of a 2.5 inch. We're talking about multiple terabytes on a M.2, a technology that by definition is a smaller form factor, but that's exactly what the client market needs. The client market benefits from low power, low footprint, low form factor, large capacity. So now you're talking about affordable solutions. So as we go from the classroom to the boardroom to all those mommy bloggers out there, we are looking at technology that allows you to do things with flash that you, to be quite honest, with the battery power and the smaller footprint, you just can't achieve with any other technology. So another dimension. And then, of course, the third dimension is the enterprise space. And in the enterprise space, I hit a button, I hope it didn't do anything. In the enterprise space, this is where flash can really come into its own. The flash was really built, and especially 3D, it was built to be big. And the bigger it gets, the better it gets. And by the way, I meant to tell you, I've got an engineer who's going to come on stage with me, so I'm kind of hurrying along to give her more time, because you really want to hear from her. And we're going to talk about 3D in a minute. But this is the market space where we see things like Facebook just talked about, where people want enormous capacity. They want to use QLC. They want to move the data closer to the CPU. So to move the data closer to the CPU, everything just happens faster. How do we do that? Well, there's two examples today. Our compute division at Micron has NVDIMM out. You can see this in our solution showcase with our partner Plexstore. And in that NVDIMM solution, you are moving a non-volatile solution right next to the DRAM. It's in the DRAM space, but it's non-volatile. Well, what's that mean? Well, it means you can do things like database login at 2 times the speed. You can do MongoDB at 8 to 10 times lower latencies. You can do 4x transaction rates. You can actually do email exchange at 63% increase just by changing to a technology like that, because you've now moved the non-volatile capability right inside the DRAM. So that's the NVDIMM solution, closer to the CPU. The other one is NVMe. NVMe is the buzzword in the industry. It's the protocol that actually talks to an SSD. Why is it valuable? Because it knows we're not a hard drive. It knows that our device does not behave and act like a hard drive. And if you treat us that way, then we have to do a lot of garbage collection cleanup to go, make it real. But when you use NVMe, you take care of a lot of that capability, and you allow the operating system and all the interfaces to work with the NVMe solution much simpler, much faster, and you have a much better solution. These kind of technologies are critical, and the one point I'd like to point out to you here is Micron plays in all three of these. There's a few other companies that do, but Micron plays in all three of these markets. So I want to get to 3D XPoint. I think almost everybody wants to talk about 3D XPoint, so I hurried through all that really cool stuff, other stuff we do. And so there isn't anybody who doesn't kind of get that 3D XPoint, it's a game changer, it's a really big opportunity, but there's a lot of questions. We introduced it with the 1000s, I like to call it, that the cell technology can deliver these 1000Xs, and I think everybody saw that, and that's very interesting. And then the next question is, well, when do I get my hands on this, and how do I get a hold of it, and is it really capable of doing that? Does it replace DRAM? Does it replace NAND? So I'm going to spend a little bit of time peeling the onion back. I'm going to take us through a little bit of a journey here, and as the business guy, I'm going to walk you through what we can do. Now, I have a technology person here at this event, and they're in one of the breakout room K at 4:20 this afternoon. So Steve Pulowski, and he'll walk you through the technical side. So I just don't have enough time to go through it, nor do I have all the insights to go through it. But what I do want to do is walk you through what we can do with this technology. So the first thing is, where does it fit? And so we're drawing a picture here, and if you look on the left, you see the DRAM. You look on the right, you see the hard disk. Well, the difference between the DRAM and the hard disk is thousands of X in performance. You cannot, if you move that disk next to the DRAM, you'll get that little hourglass spinning around. So nobody wants to see that. And so we keep them separated, and typically there's a lot of cache in the server or the desktop that does that. But as we build bigger and bigger systems, what you see is, on the right-hand side, you see the NAND SSD and even a NAND PCIe SSD. you see those things moving to the right. They're bringing that performance closer to the CPU. And you see the NVDIMM I just talked about, and you see that technology much closer. And in that space in the middle, you see this gap. This is where 3D XPoint is not is going to play significantly, and it doesn't necessarily have to replace these other two. There's a gap there that it can really fill. And so you can see as we get closer to the NAND, as we get closer to the DRAM, we need those higher performances, but we need to bring that NV, non-volatile capability with it. And that's exactly what 3D XPoint does. Now, the other point I want to make here is look across the line here, DRAM, NVDIMM, 3D XPoint, and NAND. We're the only company in the world that plays in all three of those. We are the only company that has all three technologies. So one of my bold statements that I'm going to call up my safe harbor is, I intend at Micron to own this. I intend to own this, the server, the serverification. That's the term we use, where you take a server and you use it as a storage device because you have all that CPU potential. You drop in a NVDIMM, you drop in an NV SSD like our 9100 that is, if you've seen, we shipped the 9100 Max, and it got compared to rocket ships, and we heard it was the fastest in the world. Matter of fact, one of our partner testers came back and said he thought we broke their test bed. So very, very fast technology. Well, now you can layer these technologies together, and you can build an infrastructure that literally does not have to slow down. And when my engineer gets up here, she's going to walk us through some of that. Okay, so here we go. I'm going to have to put some things down here. So get your safety goggles on, because we're going to talk a little bit about 3D NAND. And of course, I need to stop and take a selfie. You thought I was just making fun of the mommy bloggers. All right. All right, so everybody got your goggles on? Smile. Oh, can we bring those lights down? Let me get everybody in here. 5, 4, 3, 2, 1. Thank you. All right, so anybody who didn't put their goggles on is going to be identifiable in this group of nerds. Just FYI, we'll be able to post that and tell who you exactly are. So now that we've got our goggles on, let's talk about our introduction. You might have seen it in the press this morning, but what we're doing is introducing a Micron brand, and it's called, wait till it comes up, Quantex. And then this is the Micron brand. We're not rebranding 3D XPoint. What we're doing is we're going to use this brand, and you can see that building behind there. That's really cool. We're going to use this brand to deliver our SSDs. All of our solution sets are going to be delivered through the Quantex brand. And it's really a contraction of two ideas. It's a quantum leap in the technology that 3D XPoint is, and it's also very significantly based on this XPoint idea. Boy, you guys really look nerdy. I must look the same way, so I'm taking mine off. All right, so the Quantex brand, and we will use it at Micron henceforth, and you'll hear us talking about all of our solution sets branded under this name so that we can capture that value. Now, this is a quote from Tom Peters, who some of you might remember wrote The Peter Principle and several very interesting books. And in it, he basically makes a point that I want to beg off of. And this is, he talks about community grassroots organizing, and he says if you want to change things significantly, you need to build this community. And it has to be at a grassroots level. And you have to change, notice the last line, you have to change the conventional wisdom. Well, that's exactly what we're doing. So at Micron, unlike many companies who'd want to pull this technology in and hold it close and not share and be open with it, we have exactly the opposite plan. So what we're going to do is build a community. And as we build that community, we're going to use industry giants that have done this before. We're going to also partner with all of the companies that we have the opportunity to partner with. So instead of us building a very narrow set of solutions that can only go through a very narrow set of opportunities, it's our intention to make 3D XPoint through the Quantex brand a community opportunity. So this is not for the 1%ers. This is not for the usurpers. This is a true community opportunity. So in keeping with that, I'm going to, in keeping with that, that's Stephanie's slide. I'm going to invite Stephanie Woodbury up, my engineer from, where is she? Okay, there's Stephanie. While she's coming up, let me tell you about Stephanie. I've worked with her for about 10 years. She's one of my storage architects that works closely with me. I give her all the crazy ideas we have and ask her to turn them into realities. And she's kind of my chief tinkerer, and she's the head of our Storage Advanced Technology group. So Stephanie, thank you for coming up. And let me just, I will tell you that I gave Stephanie some 3D XPoint. She's one of the few people on earth that has it. And so, Stephanie, tell us what you've been doing with it.
Thank you, Darren. I'm happy to be here today. And I just want to kind of focus on one of your previous points, and that is, when we came out and talked about XPoint technology originally and talked about the performance and the endurance improvements, a lot of that was based on the science and how the science projected at the cell level. And what we've realized is, we can still get that 1000x kind of endurance and performance at the cell level, but now what's important is to take that technology and turn it into products that customers can actually use. And that's what I've had the exciting opportunity, myself and my team, to actually take that XPoint technology and start to connect that to an SSD solution. And so over the last year, my team has actually had the opportunity to take that XPoint solution and architect it and prototype it and start to play around with it in the lab. Some of the things that we've discovered is it's important to have the right controller technology, the right firmware technology, and certainly the right interface speed. So we are focusing on NVMe as the interface speed for the XPoint technology. And what we've seen through this is that you can get up to 10x IOPS over NAND at very low Q depths, and really across all Q depths once it reaches the max interface rate. We're also seeing 10x faster response time in terms of latency. So this is very exciting because we knew that it was going to be a vast improvement at the cell level, but now we're able to get it into an SSD and turn it into real technology. So some exciting stuff. So one of the things that I want to focus on here, Darren, is we have a live demo running in our solution showcase. And what we were able to do with the prototype and the architecture models is actually run those in a live system to actually demonstrate the performance improvement at an SSD level. So this is a recording of that live demo. And this is average latency, comparison of a high-performance NVMe SSD compared to a Micron Quantex technology in an SSD. So in a typical environment with the high-performance NVMe SSDs, we're seeing about 200 microseconds of writes and about 100 microseconds of reads with a typical NAND device. And this is actually an FIO script running in the background with a mixed use case, kind of a 70-30 read-write. And what this provides us is a view into how these drives will perform in an OLTP database or file server application. So the next part is very exciting because this is where we get that demonstration. So this shows us what we're seeing on the Micron Quantex.
So just to be clear, you brought this with you to this show?
Yes.
Oh.
We actually hand carried it over yesterday.
Good thing we announced it.
We're treating this with kid gloves, right? But this is awesome technology. So with the Micron Quantex technology, we're actually seeing writes at less than 20 microseconds and reads at less than 10 microseconds. So this is where we start to bring the science into reality for customers. So we're very excited to be able to answer questions at the Solution Showcase. Myself and one of my engineers will be there to talk to you about the technology. So now that we've talked about latency, I'd like to spend a little bit of time and talk about the other performance metric that we talked about in terms of IOPS. And this is in a U.2 form factor. This is PCIe Gen 3 using 4 lanes. 4K randoms, again, a mixed use environment, so similar to the FIO simulation that we were running on the previous demo. And the first thing I want to focus on is looking at NAND. So we've got a 1600 gig or 1.6 terabyte NAND device, and we're looking at 0 to 32 QDEPs. So what we see in today's high-performance NVMe SSD devices with NAND is that you need a significant amount of QDEP, right, to get to that max interface rate or IOPS. And you'll notice that the 1600 gig, even though it will eventually reach max IOPS, at 32 QDEPs, it's only about 20% of the way there, okay, in a mixed use case environment. Now compare and contrast that with our Micron Quantex SSD, and we've got a 200, 400, 800, and 1600 gig drive running in this simulation. And you'll notice that at QDEP of 4, you've already reached your max IOPS, your interface rate. And that's extremely exciting. And that's where this starts to fill that space in the tier of storage between the NVDIMM and the NAND devices.
And this was with a small drive. I mean, a 200 gig drive at QDEP of 4, you're maxing out the bus.
That's right. And it'll maintain that across all QDEPs.
Wow.
And that's very critical for high transaction mixed use workloads. And this allows the architect that's putting the system architecture together, not only are they not dealing with latency constraints, but now they know they can get guaranteed IOPS at very low QDEPs and maintain that across all QDEPs. So we've discovered what happens in a U.2 form factor with 4 lanes. So I don't want to leave out the faster 8-lane version of this, which is a half-high, half-link by 8 add-in card. So similar depiction here with the 1600 gig NAND. You're still getting to about 20% of your potential IOPS at 32 QDEP. And then when you bring on the 200, 400, 800, and 1600 crosspoint devices, or Micron Quantex SSDs, I'm still getting used to the new brand name. So
Good.
We can still see very high IOPS at low QDEPs. Now, obviously, with the half-IOP link, the 8 lanes, you're getting to a higher interface rate. So you've still got the active die contention that's necessary to get there. It's just going to take a little bit longer, but it's still incredibly fast, and with the low latency and responsiveness.
So I know our audience probably wants to know, does NAND still have a place in the market?
Oh, absolutely. When you look at NAND, it's still the best mainstream non-volatile storage. When you need to get to those higher capacities at the lower cost per gig, NAND is still the right fit for that tier. But what's exciting is now Crosspoint or Micron Quantex SSD can come in and fill that middle space. So you get the performance, you get the latency, and you get the capacity at a relatively low cost per gig. And what's also exciting, along with our live demo upstairs, we also have a 24 terabyte high capacity demo with NAND. So just a demonstration of both those technologies.
Okay, thank you, Stephanie.
All right, thank you.
Get that back. So a pretty impressive outcome for an early product that is running in a prototype lab. By the way, it's in the Suite 209 at our showcase, where Stephanie and her team will run through the demo and let you see it live. Here's an actual picture of several of the things we have going on. Remember Steve Pulowski at 420 in Salon K, and the showcase room. Oh, I'm sorry, it's 210, not 209. 210 in the showcase, and then obviously we have our booth. You're all invited now. You're a member of the community. You're all invited to come to our, we're having a cocktail hour at 7 o'clock in the Tusca courtyard. And it starts at 7, but you have to go by our booth and get your community identification bracelet. So I appreciate the time. I have 2 minutes left, but I've cleverly left myself no time for questions. But I have a lot of my team here, and we have these showcases. If you really want to know more about this technology, come and visit the Micron booth, the Micron showcase, and our Micron partners, Mellanox and Plexstore. Thank you.
Thank you. So Darren, do we need to keep these glasses?
Well, you can. I understand they're quite the fashion statement here in California.
Very good. All right.
Thank you.
Thank you, sir.
You bet.